All right. Happy Tuesday. In for Tuesday. Hey guys, it's Mac and Cheese here. We are back. You may have seen us last week talking about Terraform, Kubernetes, and CICD, and specifically about how we move fast and don't break things. So jumping into it, a little flashback to last week. So last week we covered how we actually offer value to the company as an infrastructure team. So that's building invariants, things people can depend on that allow them to build things very quickly. Part of how we do that is by using Kubernetes, which gives us the shared API for our runtime and for our development targets. But we still actually do need to provision Kubernetes. And then the way that we do that is we use Terraform. There are other options. There are even other options that we would potentially choose over Terraform today, but we happen to use Terraform because of the time if we were making this choice. And that dives right into it. The last thing we touched on before we finished last time was I mentioned that Terraform was a slow tool. So we're going to get into what slow means. We're obviously going to hit the flip side of that, which is what is a fast tool. And then as you think about slow and fast tools, how do you actually make decisions around what to provision and manage with slow tools versus what to provision and manage with fast tools? Diving right in. Yes, I did mention that Terraform was a slow tool. So Terraform was not actually slow itself. The crux of why it ends up being slow is because it manages slow things, and it's good at managing those slow things. I was chatting with one of our front end engineers the other day, and he was saying, why doesn't Terraform just work? Like, things like rsync and Git, don't have these problems of like out of consistent state. And I was like, we can get into this if you want. it's sort of a long conversation. It involves all the things that Terraform actually interacts with, which are these these APIs that have very long return times that are building real things on the back end. Where you don't necessarily know what the outcome is going to be or what you should do based on that outcome. But as a result of all that, Terraform has to move in a way that seems slow because it's interacting with these things.
Well, Terraform itself too is using consistency tools just like Git and rsync, the behind the scenes, we have the same consistencies.
Right, it's syncing back to some state system. But it's not sending slower things. Terraform, grand scheme, for what it's actually doing, Terraform is actually a very efficient tool. So the easiest way that it approaches that efficiency is it performs dependency tracking throughout your actual templates. And the way that it does this is, as you put together your Terraform and you, for example, create your VPC and then propagate the ID of that VPC into a bunch of other resources that need to consume that ID in order to have some place to run, it understands that actual variable reference as a necessary dependency. In order for this thing to run, it needs a value that is produced by this other thing. But what it can do as a side effect of that is because it understands dependencies, anything that doesn't depend on each other, it can just run all simultaneously. So again, getting back to these very slow asynchronous processes, it just kicks them all off, and you're frequently latency bound by the longest thing, which frankly is still slow.
And it's most likely your most complicated object you're working with.
Exactly. It's your Kubernetes clusters, it's your databases, it's your whatever managed service you're using. This, we touched on this bit last time, but Terraform is as slow as the slowest thing you're provisioning. So that ends up being an interesting distinction that drives what else you actually manage with it. So what we found is it works well in infrastructure deployment. Infrastructure, in the way that we think about it, is infrequent in mutations. It doesn't change very often. For the most part, you drop down a network, you put some things on top of it, and then you deploy software to those things. But you're not expecting to, for example, change that CIDR range all the time. It's disruptive, so you don't. You try to plan ahead. So the way that we think about our goals with Terraform is specifically that we want to be able to run Terraform multiple times in a row and have it produce no side effects after the first run. So specifically what we're thinking about is we want Terraform to ensure to make guarantees for us when it runs, rather than trying to make changes with Terraform. So we construct this set of guarantees, and then we say, Terraform, make it so. And then we avoid running it again, because we don't actually want those to be highly dynamic. That's not the goal. That's not useful. It's useful for them to be stable. So this does work better for stable components, things like the network, things like your Kubernetes control planes, things like your core logic plane, anything that you don't want moving around much or getting disrupted, your storage, for example. It works great. You put it there, you leave it, and you fill that S3 bucket up with files.
Yeah, if you're looking at configurations that might change more often, or maybe it's a touch point with a customer, it might not be the proper fit for Terraform.
Exactly, and we're going to get into that a little bit later, where there are some things that you may think of as these more stable components based on what kind of thing they are, but because of the actual life cycle of them, they can't fit into a slow tool. So moving forward a bit, if Terraform is slow, what is fast? For us, that's Kubernetes. Kubernetes, like you may think in the grand scheme of resource managers, it's not fast per se. I've had people. I was talking to a vendor at one point who said, "Oh, I assume that if you're running on Kubernetes, that you don't care how long it takes for pods to spin up." I said, "That's not really true. It's sort of true, but it's not really true." We don't want them to take forever, but we like the strong guarantees of consistency. But it's a hell of a lot faster than Terraform, and in particular, it's something that we don't need to babysit. We give it things, and then it figures out a safe way to get there, which is effectively a fast release process. So Kubernetes is our fast tool. It can't do all the things that Terraform can. We're not going to manage our S3 buckets, our Google Cloud storage from Terraform, from Kubernetes. Could we theoretically host our databases on Kubernetes? Yeah, we could. Is it worth doing? Probably not. Other people are good at managing databases, so we don't need to do that.
Vice versa of that, you could have Terraform manage your auto-scaling groups, but I'm pretty sure Kubernetes does a lot better job of that.
Well, and this sort of gets into the actual what is the guarantee versus what is the thing that is fast and changing at runtime. Is your auto-scaling group, you need it to exist before Kubernetes, or you typically want it to exist before Kubernetes, but you're not going to use Terraform to scale it up and down. That's a kube thing. And this also touches on a little bit of the distinction, which is, to some extent, Terraform is slow, but it's also an infrastructure deploy time tool, and Kubernetes is fast, but it's also a it's code deploy time, and also in many cases runtime is when these mutations actually happen.
Right.
So a key part of this is how Kubernetes actually understands how to perform rollouts. The way in which we can hand a new config for a deployment to Kubernetes, and we can tell it what strategy to use to perform a rollout, but the defaults generally work. They work fairly well. There may be some late disruptions if you don't have a good service mesh in place to handle like the handoffs of connections that happen to exist already, but for the most part, it's largely fine. And what this means is that you can talk about the things that you want running, and you don't have to think about how to get there. Nor do you have to wait the whole time. Second big thing, Kubernetes is the same actual deploy layer as our code. So everything is thinking on that same API layer of Kubernetes. And because we're managing our code deployments, so changing what actual Docker images that we're referencing at the same place as we're talking about our config, we get the benefit of being able to roll out dependent config and code in a tightly bound manner, which is actually really useful. We have a mono repo, and we get certain benefits from that, like being able to treat any given branch or commit as typically a safe single point in time. That's harder with Terraform, partially because of how we manage it, but it's trickier to get Terraform to run in that consistent way, super tied to Git. Terraform Enterprise tries to do this, but it's more challenging. Consistency in Terraform is harder to manage.
Yeah, you can implement the module system using Git and try to work it into your development workflow, but it's pretty tough.
So we lean more on Kubernetes in that respect, where we can just kind of throw things at it and it gets us there. We just we hit it with the whole repo, and it's like, great, cool, I got it. And we fix it if it breaks, obviously. So we manage Kubernetes manifests from Circle CI deployments. And this is where we get into the actual, like how we tie this into CICD. We don't have a CICD for our Terraform because it is slow and painful. We do for Kubernetes manifests. They are very easy to roll out. We are never more than a week out of date in our production environments. It doesn't happen because it's very easy to deploy things to Kubernetes because it knows how to deploy things. Like this matters. It being a week out of date versus being maybe a month out of date on just those little tweaks to your Terraform makes a difference. So. And yeah, part of this is that we don't actually need a planning downtime for Kubernetes releases. We deploy to Kubernetes and we just roll with it. It's not unusual because of managed services and because of the way that all the things interplay in Terraform, that there may be a provider update or something that causes us to have to do a rebuild of components that require downtime, which is more painful. Can't tie faster processes to that. And again, Kubernetes understands rollouts. So you just tell it what the new state is, and it gets you there. It effectively is running something like Terraform in the background, but it can do that safely.
This is probably one of my favorite aspects of Kubernetes and the way that it manages CPU and memory. Previously, application change or something like that would require more CPU or memory had some sort of capacity management or capacity request tied to it. Now all my developers have to do is change a couple values. They get some more boxes, less CPU. That's my favorite. but then they're off to the races.
Exactly, and we don't need to think about anything like planning a whole capacity shift to do some rollout. Like, we just trust Kubernetes to do it, and it happens. So we're less likely to get blocked on upstream provider issues, largely because of the Kubernetes API. Like, it is stable enough, is the way that I would describe it. There are breaking changes, but it works pretty darn well across releases. So then, if Kubernetes is fast, how do we actually make decisions about what deploys fast and slow? There's some pretty obvious ones. Your network, your actual VPC or virtual net, that is slow. Your buckets are very slow. I did some bucket deletion last night that took hours. It's real slow. Scaling config of your actual deployments is very fast. You're changing a number. You're changing a number that doesn't actually have a side effect immediately. It's like changing the maximum number of pods on your deployment. You just roll it out, and it's new config that Kubernetes is just aware of, and then that's part of its new scheduling criteria. So it takes seconds to roll it out.
It will turn nodes on very fast.
Yeah, it turns nodes up, turns nodes down, as fast as you need. But those aren't super interesting. The really interesting questions I find are in the middle. What do you do about the things that don't have a really obvious bucket? So, for example, DNS for external endpoints. We are actually currently of two minds on this. Traditionally, we had approached this, from a very standard, like, go to DigiCert, get your SSL creds. Actually, we still do that for all of them. But go get your certs. Set up a static external IP. Pass that into Kubernetes. Tell it what IP to map to. Tell it, go and manually change DNS to point to that. It's laborious. It's slow. And if you make mistakes and you don't catch it, it's brittle. It doesn't self-correct. What we found, though, was we started to add more endpoints to our actual environments, and there are other services that you can use. For example, we use the external DNS service for Kubernetes, which will go and inspect your clusters and see where things are running, because you can tell Kubernetes to expose a service with an external endpoint, whether that is, for example, a network load balancer that has a host name in Amazon or a raw IP in Azure or GCP. It goes and sets up that NLB, and then external DNS says, great, cool. I'm looking at that cluster. I know what its external endpoint is, and then I go and register that in DNS. So we don't need to be involved as these things roll out. It introduces the option, the opportunity for things to break as they're not babysat, but it also saves us a ton of time. And it can recover in situations where you do, for example, lose an IP for some reason. Something gets deleted, something gets GC'd, it redeploys, and no one tells infrastructure. Like, we actually don't need to know.
One of our simple maintenance with Terraform that we perform on a VPC can actually change that DNS drastically. So this is another point in place where we have in the past had these configurations in Terraform and had to try to keep up with them. But it's something that we brought into a cluster, a Kubernetes cluster solution to get that, autonomy.
Yeah, and it's a lot more painful in Terraform. It also doesn't work in certain circumstances. We found that when we came to Azure. That was the whole thing. So that's something where we're shifting more toward a fast approach of handing it all to Kubernetes and asking it to just make it happen. What about users? You need to authenticate inside of Kubernetes to work with your various services. Like your actual developers need to do that. Your services need service accounts to for example, let's say you have something that's a billing service that's checking how long things are running and how many resources they have. It needs access to do that. You also, because of the way the actual cloud integrations work across each cloud, every provider has their own way of performing authentication. So you can run into issues here. And in some cases, you actually need to do this in Terraform. For example, in Amazon, you do. In others, you don't necessarily. You can talk to the kube cluster with some operational admin account and have that provision all your user accounts. Amazon, that's not possible. So you don't necessarily get to make the design decision in all these cases. Credentials. Credentials are great. You sometimes have ones that you want that are very static, that you can get reused, that you can have some core operational service orchestrate from. But in many other cases, for example, like I don't think about service account credentials inside of Kubernetes. They just get provisioned when a pod comes up, and it just happens behind the scenes. Like no one else is handling those. Kubernetes just mounts them. Which is great. I prefer that when I can. What about your node pools? You're running things on top of your Kubernetes node pools, and can you manage those at runtime? Can you manage those from Kubernetes?
Yeah. For sure you can. There are some tunables you can set for a kubelet and certain things at boot.
Even a bit further than that, you can create and delete node pools at runtime. There's nothing that prevents that. We have actually found, for example, in the past, in Amazon, we had a lot of problems with spot availability. And we had to, we used to perform a bunch of fire drills where we would have to go and change this pool over from spot to on demand. We're getting closer to a point where we can actually have the cluster itself reconfigure that node pool at runtime just by identifying that that it can't get capacity, due to spot unavailability. And that's good. I prefer that.
So it comes down to a feature of the control plane, though, and something that Terraform probably couldn't help you with. Not in any kind of real life fashion.
Yeah, it would be harder. It's just, it gets down to the thing. It's not that it's impossible. It's harder. It's a worse fit in the way that we're using it. Kubernetes control planes, I think, is interesting. We happen to have a model in our architecture where we have a control plane, like a main cluster that runs all of our business logic, and then we have a compute cluster that's performing just like all sorts of Spark work. But effectively, nothing in that compute cluster actually matters in a persisted way. So we can tear it down, bring it back up, hook it back up to our systems. And it's today that's still managed by Terraform for us, but we're getting closer, like within the year, I think it will be possible for that to be managed at runtime.
I think for that compute control plane, we will have PVCs removed from it too, so it'll be almost stateless. Will be stateless.
Yeah, exactly. You do still need to think about the actual the state of any services on it, and that goes into your broader architecture design. What about customer tunables? We touched a little bit on this earlier. So we happen to provide the ability for customers to launch VPN gateways or SSH gateways so that they can securely get from their Ascend environment back to their own private infrastructure. We initially considered, effectively every single cloud has their own solution for doing some sort of VPN connection, whether it's VPC peering or VPN gateway to on-prem, or there's a dozen different solutions, but they're all a little bit painful. And what we realized was this is actually really easy to do at runtime. There are solutions like StrongSwan that we use for VPN connectivity. You just run it on the cluster. You give it the right left-hand config for for the IP range, and then you just feed it in the customer config for their network, and then you just connect. And we could actually rebuild the entire environment in another place, launch that same thing, and it just connects again. So we actually have this completely off of Terraform, which is a huge benefit. And it's important because when a customer comes to us and says, hey, we need you to do this thing, and we have to go turn to Terraform to do it, that means like infrastructure has to be involved. That means that we it's going to take longer, it's going to be more brittle, it's going to involve more downtime. Whereas if we can just do it on top of Kubernetes, we can avoid all those problems.
Yeah, Kubernetes allows us, we get to stand back and take a look at these traditional solutions that were really static and say, hey, can this fit into a software, networking defined solution? And then, it was really amazing. VPN and SSH just fit right in.
And they just work. It was a little bit astonishing at the time, but they do just largely just work. So what do we think about when we're making these decisions? First big thing, when does whatever we're managing need to change? And that's not really a point in time. That is a notion of, does it need to change frequently? What are the conditions that require this to change? Is it driven by a customer request? Is it driven by basic dev processes? Is it possible that some new security issue is going to come out and we're going to need to change it? What sort of interrupts are going to cause this to need to change? If it's almost never, if it's like our CIDR block, we can set that in the ground once. Then there's a decent chance that our customer will say, hey, we'd like to hook you to a private network, and then we change it. But we usually don't expect to change that more than twice. If we have, it's unfortunate, but it's very infrequent. Other things are much more frequent, and I think we found that most things fit the profile of fast, or at least you can do more if they're on a fast release cycle, which helps us to provide that value. And the next big thing is just how disruptive is it to change? Right now, we are, like I mentioned, still in a situation where we manage Kubernetes node pools and control planes all from Terraform. It's still relatively disruptive to change them. They change, much more frequently than the networks. But as we can introduce operational logic, such that we could, for example, drop in a new compute cluster and roll traffic onto it from the old cluster. Once we could do that, it becomes a lot more interesting to have this be something managed at runtime, managed very quickly, and get off of Terraform for that. So we're kind of pushing that direction for most things.
It also gives you an opportunity to look at where the customer might want to change things. So maybe the compute cluster changing was actually selected by the customer, and that's actually completely okay. If we're running these things, in cluster-based solutions, it's just a click of a button.
Exactly.
I don't have to run Terraform.
Yeah, if there's anything where you want to offer more interesting capabilities to the customer that get below the layer, get to lower layers of the platform, that becomes something that's basically required. And again, this is sort of just tied into disruptive, but how many resources are assuming this resource is a prerequisite? You can't remove the network because then nothing happens. Also, you can't, but you need it. And that's a pretty straightforward exercise for most things. So wrapping up, the reason we need to think through all this is that we offer value to the team by providing these invariants. We give things people can build on. Kubernetes helps us to do that at runtime, but we still do need to set it up. Terraform allows us to set it up in a consistent way that we can replicate across all clouds, but it's not a very fast thing to operate. We have found that some things work very well to be managed by Terraform, some better by Kubernetes. And we walked you through some of the ways we make those decisions. And broadly, how we're kind of pushing things toward Kubernetes and a faster way of moving over time. Thanks everyone for watching. We will probably be back in 2 weeks, I imagine. And have a lovely Tuesday, or whenever you're watching this.
See you all soon.